All right. Good day. Right. It is currently afternoon here, but today I'll publish this video for you for me to introduce you to your term project for this term. Okay. So because I understand, right, the timeline is not very ano tawag ito? The timeline is not very uh gracious as of right now, right? I've decided to make this term paper somewhat simple, right? Somewhat short. And basically, you will be writing a short paper that illustrates your research and understanding on a certain topic related to advanced math, right? Because of the timing of this course, right? We have chosen to, we have chosen to um, not discuss at length some of the topics so far. So right now I feel like for you guys at the very least to have a little bit of knowledge and have a little bit of practice when you are diving into a new kind of topic, a new kind of field. I feel this is the best compromise to to help you have a little bit of practice in that thing. Okay? So the topics available for claiming are included below, but instead of claiming, actually, we'll do it right now here. And the deadline for the project is 3 weeks from now, which is November 29th, Saturday at 10 p.m. Okay? Now, the mathematics used in the mechanical engineering field is quite expansive. Of course, we are an engineering course, so that entails a lot of math, right? A lot of physics as well, right? While this subject undeniably captures some key concepts in understanding how differential equations and systems of linear equations can be solved, right? The first part will go through, we've gone through analytical solutions, right? Using matrices, using the stuff we know from Calling 3. And the second part will be about brute forcing them through numerical methods. The amount of math that is yet to be discussed is quite intimidating because there still is a lot, right? Especially now with the modern state of mechanical engineering or just engineering in general, right? Every kind of engineering is somewhat related to every other kind of engineering. What we mean is that, well, at the very least for our university, if you're an undergraduate student, immediately, right, pagka-graduate nyo, you will have a mechatronics minor, right? Or parang tama, but basta focus on mechatronics engineering, which is basically a combination of mechanical engineering, electrical engineering, electronics engineering, and controls engineering, right? If you know that little Venn diagram in STRC. And so, ibig sabihin nito, right? We are not just pure mechanical engineers now. If we were, we'd be, I don't know, soldiers because we'd be looking at, I don't know, like how steam engines work, that kind of thing. But now, right, clearly we are tackling way more than just that. We're tackling also control systems, that kind of stuff. And well, all of those things at their core have their own little bit of math, right? Ultimately, the goal of this course is to expose its students to the vast world of mathematics that is used by mechanical engineers, not only in their direct line of work, but mainly in the computers that they use to aid in coming up with more efficient and more understandable principles, right? This time, right, we are now seeing the era of what, like, uh, artificial intelligence, but before we had our own kind of artificial intelligence, more in the sense of algorithms, right? So that is hopefully what MEADMAT does to us, right? Or that is what MEADMAT exposes us to. That is what MEADMAT asks us to appreciate, right? This project will focus on letting the students explore selected subjects on their own, seeing how they handle a process of guided self-learning. The thing is, in here, if you do indeed get notes from your seniors or maybe something like that, these are discussed already, right? And honestly, kayo na bahala how you would want to learn about this. Of course, YouTube has its own YouTube University na already. Basically, I'm pretty sure that if you're going to search these things in YouTube or basically in Google, you will find troves of information. And so now it is up to you how to, right, properly summarize all of the information you have gathered. Right? For your term project, you will write a short paper that synthesizes information you've gathered about a topic in advanced mathematics. Your essay will consist of several sections, all of which serve to analyze this topic in depth. You do not need to include headers in your paper, but ensure its proper flow according to the sections you will read about below. Your topic assignment will be announced on the Canvas announcement along with the publication of the primer. Your topics available are as follows. Number 1, the Taylor series and the Maclaurin series na rin. Number 2, two small topics pushed together, right? Several matrix decomposition methods and the Gauss-Seidel method, right? Or the GSM. Number 3, polynomial integration through the Lagrange interpolation and the Newton interpolation, or another name for that is Newton's divided difference. And number 4, numerical integration through 4 rules. Trapezoidal rule, number 1, 2 of Simpson's rules, number 2, and Boole's rule, which is number 2 and 3, and then Boole's rule, which is number 4. Okay, so let's start assigning these things now to you, right? So let me just get my piece of paper here. The first one will be Taylor series. Okay, who will get the Taylor series? It will be Enriquez. Mr. Enriquez will get Taylor series. Next, matrix decomposition and Gauss-Seidel method, that will be Miss Nepomuceno. That will be matrix decomposition methods and Gauss-Seidel method, GSM. Next, for Lagrange and Newton interpolation, that is Villar, Mr. Villar, which leaves us with Mr. Esser for numerical integration. Okay, so even if you don't watch this video, right, I will still be announcing this in Canvas, right? What is this? Numerical integration. All right, so that settles things, right? Now we go back here. What are the sections that you're supposed to write about? There will be 4. First, the introduction, right? And the rationale as well. For this section, you will discuss the background surrounding the invention of the method or topic. Basically, right, what has happened before and why did they need to create this method, right? Provide a simple history to the topic that has been chosen for you. What were the existing mathematics before? Maybe, right, sobrang bagal ng current nilang algorithm. Maybe there was no algorithm in the first place, right? And what prompted mathematicians to discover or invent this topic in the first place, right? Maybe their method was so slow that they wanted to optimize. And this product or this method or this topic was born, right? Was it a kind of mathematics that existed long before, say in ancient Egypt or in India? Because there are many things that come about like that. Na parang polynomials you might think is somewhat of a recent invention, but actually it's been very present na way before, right? Or was it a more recent discovery? In brief, introduce how the topic has come to be and clearly state why this topic is necessary for modern engineering mathematics. Basically the rationale, right? Why do we need to care about this thing, right? What parts of daily life, if wala ito, right, would computers have a harder time maybe computing stuff? Would ganito ganyan, right? What parts of yun nga, why is this necessary? Okay, what parts of engineering life does this make easy or trivial, if ever? Okay, now section 2, I feel like with section 3 this will be the longest part of your paper, right? Discuss the mechanics and formulas related to the topic. So the mechanics and the analysis. This section should discuss the topic or the topic or method chosen in full. Include not only discussions about the formulas or algorithms, also include comments about the performance of these methods. Basically, what I'm saying is that are there better alternatives, right? There are, of course, advantages, disadvantages. Excuse me. How easy is it to get an exact or satisfactory answer? Maybe this method may be very difficult to pull off, but it's very fast at arriving at an answer, right? How accurate are they compared to the exact answers? For the people here, for the students here who are going to think about or who are going to discuss things like the Taylor series the interpolation methods, the numerical integration methods, and even honestly the matrix decompositions and Gauss-Seidel specifically, right? What are the advantages and the disadvantages, right? As much as possible, write as if you're explaining to the reader what you have learned, right? You don't need this to be very jargony. I want you to be able to explain what you have just read, what you have just researched in your own words, right? You don't need the jargon na parang, oh, say for example, for a matrix, right? Of course, you're going to have to think of, you're going to have to mention some jargon, right? Some piece of jargon, like say, let's say for example, meron dyan, you will see there positive definite. Or maybe for a Taylor series, of course, we can't escape the discussion without saying something like a polynomial, right? So, if anything, just try and make it very simple, such that you're writing to explain to someone, right? Oh, this is how it's supposed to be. Okay. In other words, attempt to connect with the reader by using any complicated jargon only when necessary. Use math equations in Microsoft Word, which I prefer because Google Docs equations are very bad, right? And you're gonna be working alone, so why would you Google Docs, right? Anyway, for the Taylor series, you must explain what the series representation formula means. So this is Mr. Enriquez, right? And why it works for almost all functions. Almost all functions because there's going to be a little caveat in there, right? Paano kung your function is 1 over x, right? What happens near the x equals 0, right? Pictures are allowed, so you may include screenshots of graphs and other related graphics to illustrate your point. Okay? Comment on the accuracy of using more Taylor series terms and approximating the original function. As much as possible, cite any pictures you have not made yourself. And I suppose this is going to be common to everyone else, right? Of course, a good part of our learning, especially for us engineering students, for you engineering students, is visuals, right? If we don't see it, there's a part of us that does not believe it, right? So, for that to happen, you may need some pictures, and of course, just go ahead and cite whichever pictures that you have not made yourself. Okay, kasi you can make stuff like, say for example, this I've made this myself in Desmos, right? If you want to maybe think about things in terms of Desmos, then maybe you can just what do you call this? Take pictures, take screenshots of this. And of course, if this is coming from another person, maybe you're gonna have to cite or credit those people. Okay. For the matrix decompositions and Gauss-Seidel method, explain how to perform these decompositions and algorithm step by step. What I mean by the algorithm is the Gauss-Seidel method, right? That's an iterative method. So how are you going to do it? For the matrix decompositions, the only things I need are the LU decomposition and the Cholesky decomposition. Technically, other stuff, right? Other methods like the QR decomposition, you don't need that, but if you want to, go ahead, right? And following this, provide the advantages and disadvantages of using each method. And the thing by this is what constitutes good, right? What constitutes easy, what constitutes fast. Yun ba yung definition natin ng good, right? So you're going to have to comment on that yourself, right? That is Miss Nepomuceno. Okay? For the interpolation methods, explain how to perform each method and compare the Lagrange interpolation with the Newton's divided difference method. So you're going to compare them first, right? Maybe which one is better, which one is easier, which one is more accurate, so on and so forth. This is Mr. Villar. Right? And cite other interpolation methods available, right? What other interpolation methods are there? Of course, we know linear interpolation, right? Maybe we know linear regression as well, right? And now you compare those two methods, the Lagrange and Newton method, with those other methods that you can think of, right? And then lastly, Mr. Esser, for numerical integration, explain the 4 rules, right? So, trapezoidal rule, right? Simpson's rules, so there are 2 of them, and then Boole's rule. I think that's Simpson's 1/3 and Simpson's 3/8 rule, and Boole's rule. If you want, you can also include in here, say for example, Riemann sums, right? Um, integration via quadrature, that is also possible, right? And for this, because this is going to be integration, I feel like you're going to have to include some graphs just to make this somewhat visual. Okay, other graphics that may be necessary to illustrate your points. Compare each method and weigh their advantages and disadvantages. Okay, so that is for your section 2. And here, to be clear, you're not advocating for your chosen method. If, say for example, we find out that the LU and Cholesky decompositions are actually very bad in the sense that, oh, they're hard to do, they're not very accurate, okay, doesn't matter, right? What matters is that you actually do come to this conclusion because of your research. You can't just say that, oh, my method is good. Oh, the Lagrange interpolation method is good, period. Based on what? Evidence, right? Based on what kind of research? Okay? That kind of thing. Okay? Do not distort your research to be partisan to your topic, right? This is not a kind of a debate wherein you're supposed to advocate for your or against your topic. You're just trying to research. Okay? For section 3, you will use these topics in answering at least 2 questions. At least one, which is easy, quote unquote, and at least another one, which is a bit more difficult, right? Think about this like your sample computations in your lab reports, okay? And then, unlike those lab reports, because I know when you're doing sample computations, what usually just happens is that you just have a bunch of equations and then boom, right? What I mean to say now is that please use both formulas and words, right, in explaining your solutions. Okay? All right. And then the last one in here is just a little section on further reading, right? This functions like a Wikipedia article na parang at the end of it, right? Okay, if you've digested that whole article, if you've digested the what do you call this? The topic itself, what next? Right? Is there a harder version of this topic? Is there a more difficult or a more complicated way to apply this topic? Right? Maybe a real life application, right? Maybe, oh, it's just the next topic in the parang the broader scheme of things, right? You guys decide what you would like to provide the what you would like to suggest the reader what to do next. Okay, so those are your 4 sections. The thing about this is that I'm not requiring this to be very heavy, right? This is just for us to just explore more about engineering mathematics. So that means the essay must consist of at least 1,000 words. So medyo konti na yan, right? Pictures are allowed. There's no minimum page count. Don't worry about it. And do not put a title page, okay? I don't want to see yung parang like DLSU logo and then blah 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 in partial fulfillment. Don't worry about it. Just put your name, your ID number, and your section, and then that's it. Actually, kahit no section, just it's fine already. Right? The document details are as follows. The document should be on letter-sized paper. The file name should be your last name. So for example, Kalangi, all in caps, and then MEADMAT Term project.pdf. So you're going to submit a PDF. The margins should be 1/2 inch on all sides. The font size is 12. The line spacing is 1.5. Note that this is different from your normal line spacing, which is 1.15. And the font style is any serif font, basically any fancy font. So not this, right? Not this font, but these fonts right here. Okay? So stuff like Times New Roman, Cambria, gonna. Okay? And then the text should be justified. And if you have any citations, please follow APA. Right? And not following these instructions results in a -3 for every bullet point not followed. Improper in-text citations, hallucinations for DOI links and the like will receive harsher reductions because, well, this is citation we're talking about. Okay? So the goal of this project is for you yourself to investigate various topics in advanced engineering math. While I am not restricting the use of large language models as a tool to gather and synthesize information for your essay, I am restricting the use of LLMs in actually writing the paper. Okay? So you can use the ChatGPT or the Gemini to help you with summarizing stuff for the paper, but I would like you yourself to write the paper. I'd like to see your own writing style shine through, even if you think it doesn't sound as verbose or as well spoken as you would like it to be. I'm allowing the use of tools like Grammarly if ever you're very conscious about your grammar, but please declare the use of such tools in a short italicized paragraph before the beginning of your essay. Okay? Yun lang. I'm just asking that. Right? Because if, say for example, I'm expecting a human-made work, and then suddenly I see stuff like different headers, so may mga emoji, and then lots of M dashes. Sad to say that like the M dashes are now parang massive points or massive pointers na nga for non-human made work, right? But yeah, there you go. Just please declare. Okay. The deadline for this project is, again, 3 weeks from now, November 29, 10 p.m. 10 p.m., huh? There will be no extensions. The highest possible score will decrease by 10% for every 24 hours that pass after the deadline, bottoming out to 50% after 5 days. So say, for example, you submit November 29, 11:30 p.m. because you said, it's 11:59. No. That will be 90 na ang highest nun. Okay? For every 24 hours. So again, next day, 80 na lang, 70, 60, 50. Right? Early submissions will be incentivized. Submissions made on week 11, so November 10 to 15, will warrant a plus 10 quiz score. Submissions made on week 12 will warrant a plus 5 quiz score. That is on November 17 to 22. Okay? Ayun. Yun lang naman. And then you have here a little rubric at the end, just so you know what I am expecting. Right? You have content, you have accuracy and critical thinking, and you have grammar and cohesion. Right? What I just want is somewhat of a comprehensive essay. Right? I know that I'm asking for a short paper, but in my defense, these are short topics din lang naman. Right? The different details and graphics provide a clear image as to how the method works. Right? If you want to include graphics, please include graphics that actually help. Right? And of course, ito na rin yung sa dulo, yung further reading, right? If your suggestion for the reader is correct, if it's good, and then that's good enough that warrants an excellent grade. Okay? The information presented and used in the paper is shown clearly and is accurate if ever there is any data, right? And the mathematical principles mentioned are true and manipulated in a truthful manner. Okay? Advantages and disadvantages are presented critically and objectively. That is for your accuracy. And for grammar, this is just grammar things, right? I would expect you to use word choices, right, that are befitting of college students. Okay? Yun na lang. The paper is spaced correctly because there is an introduction, a body, and then the conclusion, which is your further reading. And of course, the grammar and flow of the piece make for a satisfying read. Right? In this case, the grammar is not something I'm very worried about unless your work makes me do something like this. Right? It makes me double take, and then I would have to read your sentence again because I didn't get it the first time around. Right? When we have little grammar mistakes, I get that. Don't worry about that, right? So long as I can understand what you're talking about, it will not make me stop reading, right? But, for more unrecognizable sentences, dun ako mapapatigil. And of course, dun ako mapapatanong na, what happened? Right? So yun, that is your term project, right? Very quickly, right? And I believe like with a day of research, you can get through everything, and with perhaps another day of writing, you can finish everything naman. Okay? So this is going to be a short paper, and if you guys have any other questions, please let me know. But with that, that's it for now. I will see you on more videos now about root finding, algorithms, and numerical solutions to differential equations. Okay? Thank you guys.